Let us look at proposition number 27 of book 3 of Euclid's Elements. The proposition says, in equal circles, angles standing on equal circular segments are equal to each other, whether they are at the center or at the circumference. That means angle BAC is equal to angle EDF and angle BGC is equal to angle EHF, provided BC circular segment is equal to EF circular segment. Okay, let's see how we can go about proving this. Let's do this by contradiction, proof by contradiction. Let us say that angle BGC and angle EHF, they are not equal. That means one of them has to be greater. Let us say BGC is greater than EHF, right? Now, let's take a point between B and C on the circle and let's join GK and let's mark this angle. Now, we are assuming that this angle BGK is equal to EHF because we started with the assumption that angle BGC is greater than EHF. So, we have taken a point and assumed that BGK is equal to EHF. Now, if these two angles are equal, that means what? The circular segment BK is equal to EF. Now, if BK is equal to EF, but we are already given that BC is equal to EF. So, that means BK is equal to BC, which is against our assumption that the K is not on C. It is in between B and C. So immediately we have reached a contradiction. So that means K cannot be anywhere in between. Even if we take it here and we start with the assumption that BGC is less than EHF, then also we will end up with the same contradiction. So since we have reached a contradiction, that means our assumption was wrong, and that means because of the contradiction, we can say angle BGC is equal to angle EHF. Again, based on one of our previous proposition, we know that angle BAC is going to be half of BGC. Similarly, angle EDF is going to be half of EHF. Since these two are equal, that means half of these angles will also be equal to each other. That means angle BAC is equal to angle EDF. So we have proved that if these circular segments are equal, then these angles standing on these equal circular segments are also equal to each other, whether they are at the center or on the circumference. So that is proposition 27 of book 3 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share it. That's it for now. Bye.